In our previous video, we were working with these data on heights of males and females, and we did a frequency count which showed us how many males and females there were, and also how many people of each height there were. But I mentioned that a frequency count might not be the most interesting thing for the height data. Um, Instead, we might want to calculate things like means and standard deviations to determine what the average height is, and how spread out the heights are around that average. So these are called measures of central tendency and measures of variability. Collectively, they're called descriptive statistics because they kind of describe what a set of numbers look like. So let's start simple. Once you have these data entered in, and remember, this gender information, it looks like it says female and male. It's actually numbers that I have value labels for. So if you're at all unsure about that, watch my previous video, see how I did that. Once you have these data entered in, go to Analyze, and go under Descriptive Statistics and choose Descriptives. When this window pops up, move over any variable you want to analyze. So I want to start with height and just move that over. And while we're here, I want to click on Options to specify what kind of calculations we want to run. And each one of these boxes represents a different descriptive statistic we can run. Some common ones like mean, standard deviation, minimum, maximum, those are checked by default. And there are a few others you could do like sum and the variance and the range and the standard error. I think the ones we have now are good, so let's just continue the way it is. Continue, and now hit OK. You'll see a table pop up, and I'm going to scroll down so I can just focus on these things here. This is the table we got for our descriptive statistics. It tells us of all the different scores, first off, how many of them are there. We had 10 different height scores. The smallest one was 61 inches. The highest one was 80 inches. And the average of all the heights was about 69.2. We also over here have the standard deviation, which tells us about how spread out the scores are around that mean. So let me show you something cool. Go through this again, go up to Analyze, and under Descriptive Stats and Descriptives, there's a little box down here called Save Standardized Values as Variables. I'm going to check that and hit OK. I get exactly the same table the second time, but if you go back to your spreadsheet, you'll notice a new variable appeared here. It's called z-height. And do you know what these are? These are the z-scores. It converts each height measurement into a standardized score that says how many standard deviation units away from the mean this score is. And so negative means it's a little bit below the average. A positive score means it's a little bit above average. So that's a quick and easy way to get z-scores in SPSS. Now let me show you something else. Try getting the descriptive statistics for gender. I'll just hit reset and now move gender over. Click OK. Now, remember, even though these say male and female, it's really ones and twos. So back to the output window, this table right here at the bottom. Well, it's telling us that there are 10 different scores. The minimum is 1, and the maximum is 2, which is kind of a duh because we only have two numbers, ones and twos. And the average score is 1.4. Well, I don't really think calculating averages or even standard deviations is appropriate here because these are nominal data. If 1 represents male and 2 represents female, what does 1.4 represent exactly? I don't even want to think about that, so let's do another kind of analysis. Instead, I think it might be more interesting to compare the heights of males against the heights of females. So instead of kind of sorting and separating these scores into males and females, we can have SPSS just report the average of all the heights next to female versus all the heights next to male. So to do that, we'd go up to Analyze, go down to Compare Means, and pick Means. Another window is going to pop up with boxes for dependent and independent. Dependent is where you move the values that you want analyzed. So if you want to know the average heights, you ought to move height over to the dependent list. Likewise, Independent is like the grouping variable, and we're grouping the height scores into males and females. So let's move gender down here to independent. When we have that all entered in, I think we can just click OK. Now we see a few more tables. This first one I don't think is very informative or interesting. I'm going to focus more on the second one, report. So it tells us the average height for all females at about 68.33 inches tall. And how many females there were, 6, and the standard deviation of all the female heights. And right below that we have the average male height, about 70.5 inches. There were 4 males in that data set, or in that sample, and standard deviation is about 5.91. And finally, there's total, which says the average height for all our people, regardless of gender, how many of them there were in the standard deviation. If you notice, this is actually the same thing as what we got above here. Where is that? I think, yeah, this is it. Here's the average height, 69.2 inches for all 10 people. So that's kind of cool, but it separates it into male and female. So that's how you do some simple descriptive stats used to compare groups. I think the next step is to compare different groups statistically using t-tests, and I'm going to cover that in later videos.